Good morning, everybody. Today we are going to have our second TAG meeting for the assessment and evaluation of advanced solid waste management technologies for improved recycling rates in Florida. My name is Duygu Yaşar, and I'm a PhD student in the Department of Industrial Engineering, and I'm working under the advisor of Dr. Nurçin Çelik. And here is an outline for what we are going to cover today. First, I'm going to explain our motivation to conduct this project. And then we will go through our project progress overview to remind what we did in the last TAG meeting, what we are going to do today, and in the next TAG meeting. And then it's followed by the explanation of our data collection states and count categorization process. And then I'm going to present the AHP models, analytical hierarchy process models for the evaluation of technologies. Then I will give some more information about the technologies that we evaluated. These are thermal treatment technologies and biological treatment technologies. And I will explain the results, what we obtained from AHP models. Then we didn't consider it in our evaluation for technologies. I'm going to explain why. Then we will have our discussion part. So municipal solid waste generation increases every year. And in Florida, 48% of these growing waste was discarded to landfills last year, and where the greenhouse gas emissions released actually. And landfills have limited capacities. And also, we lose the potential benefits that we could obtain from conversion of waste. So in the light of these challenges and problems, Florida established an ambitious goal, which is 75% recycling rate goal to be achieved by 2020. And there are several ways to increase the recycling rates, such as, for example, manufacturers can be encouraged to use recyclable packaging materials in their productions, or people can be educated to throw away the recyclables separately. But we are going to focus on another direction in this project. Advanced solid waste management technologies can be utilized to convert the waste into usable products, marketable products, and energy. And our aim in this project is to assess and evaluate these technologies before their implementation in Florida. So here you can see our project progress overview. In the first phase, we identified our problem and technologies to be evaluated. We presented the first phase in the first TAG meeting. Then we collected our data related to technologies to be evaluated, and then we implemented AHP, which is a multi-criteria decision-making method. And this method has a hierarchical structure of goal, criteria set, and alternatives. And subject matter expert opinions should be obtained in order to rank the criteria sets based on their importance. And these rankings are converted into pairwise comparison matrices using a scale of 1 to 9. We presented it in the last TAG meeting, but I just wanted to remind briefly. These two, the phase 2, is what we are going to have in this meeting. And in the third phase, which we will present in the third TAG meeting, we will conduct sensitivity analysis for all groups of counties. And lastly, we will give recommendations for each group based on AHP results, sensitivity analysis results, and based on your feedback that we will obtain today. So here are data collection states. First, we needed to define the criteria sets. What's important in the evaluation of advanced solid waste management technologies? We explored online sources, publicly available sources, and then defined 13 criteria for the evaluation, which we actually discussed in the last AG meeting. And we then collected the data, technology data related to these criteria list. Then we categorized the counties. Because of the time and data limitations, we needed to have enough number of counties, enough number of subject matter expert opinions for the calculation of criteria weights, and then we categorized them. First, we categorized them based on the least recycled waste type, which are food, paper, and plastic for all counties. And then we again categorized them in the second step based on the annual waste generation amount. So we have 8 groups in total. And then we obtained the rankings from subject matter experts in the solid waste management divisions in each county, from each county. They are from different backgrounds, but all of them are related to solid waste management files. So this is the county categorization, the results of county categorization process. We have 8 groups in total. The first group, for example, consists of 10 counties, which includes Holmes, Liberty, Dixie, Madison. This group has the least recycled waste type in food waste, as you may recall from the previous slide. And the second group, which are the counties colored in gray in the map, consists of 10 counties again: Glades, Taylor, Franklin, DeSoto, and you can see the rest. Alachua County is in third group, while Miami-Dade and Broward counties are in group 5. And until group 5, food is the least recycling rate waste type. Group 6 and 7, these are papers. And the last one has the least recycling waste type in plastic. So here are the AHP models. We evaluated the technologies under 2 main categories, which are thermal technologies and biological technologies, biological treatment technologies. Advanced thermal technologies are gasification, plasma arc gasification, and pyrolysis, and they were evaluated with respect to 13 criteria. Advanced biological treatment technologies are windrow composting, static pile composting, in-vessel composting, and anaerobic digestion, and they were evaluated with respect to 7 criteria. We eliminated the 6 of the criteria from this list because biological treatment technology performances were really similar or same based on the eliminated criteria, so we didn't consider them. And before I present the results of AHP, results of our evaluation using AHP, I wanna give some information about the technologies. First, I will give some information about thermal treatment technologies. Plasma arc gasification, actually, for thermal treatment technologies, their process steps are so similar, but they use different kind of equipment to process waste, and the oxygen amounts in the environment and the temperatures vary between the technologies. First, the feed, which is the waste, is handled, and then recyclables are sorted out from the handled waste, and then plasma torches are used to process the waste. Then the output gas is cooled down and then sent to syngas cleanup process in order to make it ready for power generation. San Luis County in Florida was going to implement the first plasma gasification facility in the United States, but the project was cancelled. Based on the publicly available sources, the problem might be the financial issues. The estimated capital cost for the project was $450 million. Tipping fees were estimated as $30 per ton, 6 gasifier units were going to process 500 ton of waste per day, and was going to generate 22 megawatt power from this waste. What are the advantages? It doesn't produce harmful emissions or produce in negligible amount because the system is closed system. System is a closed system. It doesn't form bottom ash or fly ash, and the waste conversion rate ranges between 96% and 98%. And feedstock can be mixed, such as tires, hazardous waste, biomass, and solid waste. Municipal solid waste can be mixed. And what are the disadvantages? The process requires frequent maintenance and component replacement, which causes frequent facility downtime and reduces the efficiency actually. And there is no commercial facility in the United States because the project was cancelled. So the second one is gasification process. First, it's actually similar to plasma gasification process, but this time the gasifier units are used in order to process the solid waste. And Tyler Biomass Montgomery project is going to be implemented, and the capital cost based on the information that we obtained from them is estimated as $150 million. And design and construction is planning to be completed in 18 to 24 months. And 300 ton of waste per day is going to be processed and generate 23 megawatt energy, 22 megawatt power. And advantage, because of the low oxygen environment, the emissions are low also. 90% of the generated energy is available for end use for the consumers. And it's a proven technology for municipal solid waste conversion in the United States as well as in the world. And it's flexible for different kind of inputs. What are the disadvantages? The process releases harmful compounds like halogens, alkalines, and heavy metals, and they can ruin the gas turbine, and they can cause actually acid rain. And pyrolysis is the last thermal treatment technology in our evaluation. It uses pyrolytic converter for processing the waste, and waste should be pre-processed and recyclables should be sorted out, just like gasification and plasma gasification. International Environmental Solutions Company has a pilot facility in California, and the capital cost of the facility is $33 million, while the tipping fees are $45 per ton, and the facility can process 8 tons of waste per day. And what are the advantages? It's similar to gasification due to the low low oxygen environment in the process. It releases low air emissions. Because of its modular design, it's flexible for different amounts of inputs, and it can convert up to 90 to 100% of the waste input. And it's a proven technology in the world. And what are the disadvantages? It requires the waste to have a moisture content less than 10%. So it makes it infeasible for large scale, for really large scale, because then the input waste should be dried in order to satisfy the limitation of the process. And the produced gas needs to be treated further after process because of the high carbon dioxide concentrations in it. So here is the result for the first group of counties. The AHP criteria weights, they are calculated from the subject matter expert opinions that we obtained from counties. And as you may recall from the previous slides, the least recycled waste type was food waste for this group. And the most important criterion is public acceptability, while the least important criterion are net conversion efficiency and the number of facilities in the United States. The second group, again the food waste, was the least recycled waste type. The most important criterion is environmental impact, while the least important one is again number of facilities in the United States.
Mm-hmm.
Third group includes the Alachua County in it, and the most important criterion is revenue, while the least important one is ease of permitting issues. Group 4, this one again was had the least recycled waste type in food waste, and it has the most important criterion as capital cost, while the least important criterion is land take-up facility, land requirement of facility. Fifth group is the last group in the food waste section, food waste group category. The most important criterion is capital cost, while the least important one is land requirement of facility again. And Miami-Dade County and Broward County are in this group. Group 6, paper waste was the least recycled waste type in this group. The most important criterion is revenue, while the least important one is number of facilities in the United States. And the last group in the paper waste category is group 7. The most important one, public acceptability, while the least important one is flexibility of process. Group 8 is the last group in our categorization. The most important criterion is tipping fee, while the least important one is land requirement of facility again. So we incorporated the criteria weights that we obtained, that we calculated for each group, and technology data together to obtain the global weights of technologies in order to select the most appropriate technology for each group of counties. So first we needed to check the inconsistency ratios of the groups. Because of the bias in human judgments and the shortcomings of the 1/9 scale, inconsistency ratio can be higher than 0.1. In this case, subject matter experts are asked to rank the criterion again, reconsider their rankings, and data collection should be checked again. But in our case, we are in safe side. For all groups, gasification has the highest ranked score, while the pyrolysis has the least ranked score. So the result looks suspicious. We wanted to check the groups separately. As you can see, in group 5, plasma gasification weight and the gasification weight are really close. And in group 8 as well. Plasma gasification weight and gasification weight are really close. So we wanted to conduct a sensitivity analysis, which we will continue in our next report. We chose group 5 in order to conduct it because plasma gasification and gasification weights are close, and Miami-Dade County in this group. So capital cost was the highest ranked criterion in this group. And we wanted to reduce the weight of capital cost to see how it changed the results. And then in AHP, the sum of the criteria weights should be equal to 1. So when we are changing one of the criterion weight, we should be changing at least one more criterion weight too. We chose marketability to be changed as second one because performances of these three technologies are so close to each other with respect to marketability. So we can say that the change that we made actually was mainly because of the change in capital cost. Morning. So after our analysis, plasma arc gasification became the highest ranked technology for group 5. This is because plasma arc gasification has a really high capital cost, which reduces its global weight for its selection. So when we reduce the weight of capital cost, it reduces the impact of bad impact on plasma arc gasification selection. We will conduct the sensitivity analysis for other groups as well. So now, before I present the results for biological treatment technologies, I want to give some information about them first. Windrow composting is the most prevalently used composting method for large-scale composting. The system consists of mainly the rows of turning piles, and turning the windrows frequently reduce the odor issues, but it increases the operation costs. Capital cost range between $40 to $60 per ton per installed capacity ton, and the land requirements, we obtained the land requirement for all 4 biological treatment technologies based on the same assumptions. So land requirement is 47,000 square meter, and the waste reduction efficiency ranges between 30 and 55%. And the finished product, which is compost, can be obtained in 6 to 12 months with windrow composting. What are the advantages? It produces a uniform compost because of the rotation of piles, and it requires really low capital cost compared to other biological treatment technologies, and it requires lower energy input compared to other biological treatment technologies, and it produces large quantities of compost because it's suitable for large-scale composting. What are the disadvantages? It requires large land area, and since the system is open to the environment, it gets affected easily by the weather changes, and their capacities are limited by the size of their turners, and it emits odor and dust. And static pile composting, the process is really similar to windrow composting, but there is no pile rotation in this system. It's done automatically. It's mechanically simple, and it requires less manpower because it doesn't require any rotation. It has a wide range of capital costs, but in order to compare to other technologies, it's higher than windrow composting and lower than in-vessel composting and anaerobic digestion. The waste reduction efficiency ranges between 30 to 55%, and a finished product, which is again compost, can be obtained in 12 to 18 months. What are the advantages? It prevents the creation of anaerobic conditions, and it doesn't require any pile rotation, which requires the manpower and operation costs. It's suitable for large scale of composting, and it's suitable for different kind of inputs like livestock manure, yard debris, and food. What are the disadvantages? It again requires a large land area, and it takes long time to produce a compost compared to windrow composting and others. And large volumes of air is produced at the end of the process to be traded. And temperature should be monitored closely because there is no pile rotation. It should be observed closely, precisely during the process. In-vessel composting is the third biological treatment technology to be evaluated. They are closely monitored aeration systems. The process parameters can be controlled precisely and automatically, It requires no manual turning, and it requires qualified workers because of the automated system. Their capital cost is higher than windrow and static pile composting, range between $300 and $500 per ton. Land requirement is less than first two composting methods, 17,200 square meter, and the waste reduction efficiency is averagely 75%, and a finished product can be obtained in 3 to 6 months. An advantage, it's not affected by weather changes because the whole process occurs in a vessel, in a closed environment, and it releases less odors, negligible amount of odors, and it requires less land area compared to first two, and it produces high quality compost. What are the disadvantages? The system is more complex, and it's not flexible to handle different amounts of waste because the capacity is limited by the size of vessel, and it requires high investments and operation costs. The last biological treatment technology that we are going to examine is anaerobic digestion, and here you can see the process steps. First, the waste is pre-treated to make the size of the waste uniform and to take the recyclables out. And the pre-treated waste is taken into digester, and then biogas or compost and fertilizer can be produced from the process. Capital cost is the highest one for anaerobic digestion compared to other three technologies. Their capital cost ranges between $500 to $700 per ton, and the least range requirement is for anaerobic digestion, and 55% waste reduction efficiency can be obtained from this process, and the finished product can be obtained in 6 months. What are the advantages? It can generate renewable energy, which is biogas, and it can be used in any scale, and the greenhouse gas emissions is less because of the closed environment, system. What are the disadvantages? It requires high capital and operating costs, and for large scales, big vessels are required, and also another equipment should be established for the treatment of produced biogas. So our criteria weights that we calculated for biological treatment technology evaluation. The first group, public acceptance, is the most important criterion. The least important criterion is the efficiency. For group 2, the most important criterion is environmental impact, while the least important one is public acceptance. For the third group, which involves Alachua County in it, the most important criterion is operating costs, while the least important one is land requirements for the facility. Group 4, capital cost is the most important criterion, while the least important one is land requirement for the facility again. Group 5, which also includes the Miami-Dade and Broward counties, the most important criterion is capital cost, while the least important one is land requirement for the facility. For Group 6, the food waste type category ended in Group 5, and these are the paper waste categories. Capital cost is the most important criterion, while the least important one is efficiency of the process. Group 7, the most important one is public acceptance, while the least important one is operation time. And the last one, which is Group 8, the most important one is capital cost, and the least important one is land requirement for the facility. So we incorporated again, we did the same process that we did for the thermal technology evaluation, and we incorporated the technology data and the criteria weights, and we obtained the results. Again, the inconsistency ratios are below 0.1, so we do not need to do any revision for the model because it's satisfactory. For group 5, which involves the Miami-Dade County and Broward County, in it the static pile composting has the highest ranked technology. For groups 1 and 7, in-vessel composting has the highest global weight, and for the rest of the groups, which are 2, 3, 4, 6, and 8, anaerobic digestion has the highest rank score. Here you can see windrow composting, the blue ones, static pile composting, red ones, in-vessel composting, green ones, and anaerobic digestion, purple ones. And so there are 4 technologies that we did not consider in our evaluation because we did it based on the feedback that we obtained in the first TAG meeting. Because those technologies do not have any implementation in the United States. Steam classification exists only in California as a testing program, and we contacted them to make sure if there is any available data that we can use in our evaluation, and they responded as there is no available data for revenue, capital cost, operation cost, and so on. And hydrothermal carbonization, there is only one demonstration facility in Germany. We sent email requests for obtaining the technology data, and we couldn't get any response from them. And catalytic cracking and depolymerization, no available data exists related to our criteria sets. There is one company that claims in their websites that they are the technology providers, which is Green Power company. And from the contact numbers that they provided in their websites, we tried to contact them, but those numbers weren't even in use, like weren't available to reach out. So our team members, Dr. Çelik, Dr. Nurçin Çelik, assistant professor in the Department of Industrial Engineering. I am Duygu Yaşar, a PhD student in the Department of Industrial Engineering again, and Merhat Bastani, he is a PhD student in the same department as well. And thank you for listening.